One of the key benefits for using Haskell is its incredibly flexible and powerful type system. And so far we've only worked with basic types, but we've seen things like polymorphism, we've seen higher order functions that allow us to make incredibly generic and powerful functions. They can work on many types with very little code. Now, today what we're going to have a look at is declaring our own types, how to define our own types. And to start with, we're just going to be looking at enumerative types. That means you define a set of values and an element of that type just takes one of the values from the set. So that could be something like days of the week, Monday to Sunday. It has to take a value from Monday to Sunday. And this is quite a simple place to start with. So today what we're going to do is we're going to define a simple direction type. This is going to tell us to go up, down, left, right. And we're going to apply that to show our type working with some coordinates. So to start with, we're going to use the keyword data. Now this declares a new data type. There is also new type, but we're going to stick with data for the moment. And as is tradition in Haskell and most function and programming languages, we call our types with a capital letter. So this is going to be our data type, and it's going to be called dir for direction. Now, we define our types, or the values of our types, similar to how you've defined grammars when you were working with John in first year, or in any of your other classes. But our directions are going to be up, down, left, or right. So the way that we declare this is our types have an uppercase as well. So this is going to be up. And then we separate the values out by the bar. So this is like saying it can be up, or it can be down, or it can be left, or it can be right. And that's our type defined. So it's very simple in Haskell to define a simple type. We'll get on to defining more complex types as we go along. But this is a very basic type, and it's taken us 2 seconds to define it. Now, of course, we can define our own functions on this. So we're going to use this to define a little coordinate system. So we give it a list of directions, and then our system will map that onto a coordinate, and we'll see where we've gone to. So let's define this. So something which takes a direction, and we're going to represent a coordinate as a tuple type, as a tuple of ints, and it should return a pair of ints. So what does this mean? Well, this says this is something that's going to be doing something along the lines of, if I tell you to go up, then you should move from 0, 0 to 0, 1, because you've moved up 1 on the y-axis. If I tell you to go right, you should go from 0, 0 to 1, 0, because that's one step right on the axis. So I've defined my type, and that means that in Haskell I can now pattern match it over the values of it. Because it's an enumerative type, I know that there's finite types, so I can just define the value for what the behavior should be for each of these values. So if I say up, and I get a coordinate of type x and y, then all I need to specify is that I get x and y plus 1. Because that's a step up 1 in the y-axis. Remember, the y is the vertical axis, x is a horizontal. And then I can just continue to pattern match. So let's say we say go down, and we have an x and a y, then this should be equal to x and y minus 1. And similarly, we can just go through each of our values and define the behavior for each of these. Now going left should take me to x minus 1, because I should go one step to the left. The left is negative in this case. And then finally for go right, I have an x and a y, and that is equal to x plus 1. So this is one of the great things in Haskell, is that you can go very quickly from defining a type to defining behavior on those type, because all of the behavior that you're used to working with, whether it's pattern matching, recursion, will work on those types. So let's save this, and now down here, something I've hidden away, is a little function here. So this is going to test our value, so I'll just bring this up here. So this is just going to map the go function over a series of values. Fold is just another higher order function. We haven't seen that yet. We'll get onto more of that later on. And if I save and reload this file, then I can call try. And you can see it's going to execute a bunch of these directions with the go function starting from the origin. So if I hit try, then I get to 5 minus 8. So that's what this is doing here. If I make this simpler and I just delete all of that, and I just go right 2 spaces, that should take me from 0, 0 to 0, 2, or from to 2, 0. So let's try that. And we go to 2, 0 as we would expect. So this is a very simple introduction to type. I just want this to motivate the idea of how we define types, the very basics. We'll go on to more complex types in the next video, looking at more enumerative types, type constructors, combining types, and then we'll go on to recursive types later on. I hope you found this useful. Again, this is just a simple introduction just to show you that you can define your own data types very simply, and then of course you can use them to define a function as you would for any other type. But of course, if you have any questions about anything I've covered here today, you're more than welcome to get in touch. Thanks.